The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show. We have a special guest with us today. Want to tell us who you are?
I am Todd Rogers, known as the King of Video Games, and I am credited with having the longest held video gaming world record.
Right, Dragster. But now there's been some debate about that record because people are basically creating mathematical models that are showing it's not possible.
Yeah, I hear about that. That's strange. But the story behind that was I submitted a Polaroid picture in 1982 of the 551 that's in question. It was about March or April of that year, and Activision called me on the phone and said they wanted to know how I shifted my Dragster comparative to their computer model. So they didn't tell me they had a computer model until after I explained how I shifted. And then they invited me out to the 1982 Consumer Electronics Show in Chicago in June of '82, where I performed the second 551, the first 551 live at their event. They were so impressed with my abilities that they invited me then to Electronic Things Show in Detroit, where I again, for the second time at a live event, performed another 551 on the game.
The idea here is that we've made hardware that can hook up to a real Atari, so we can plug these theories into the hardware and have it play it on real hardware. Okay, so in a previous episode, I made a hardware device that attached to a real Atari and allowed you to look at the RAM and make decisions based off it. What we're going to do today is use Todd's information and plug it into my system so it can repeat the kind of gameplay he did back in the 1980s. So the computer can do it perfectly. So if we give it the numbers to try, it will do it every time. It can always start on the right frame. A human has only a 1 in 16 chance of doing that, and it doesn't get tired, its hands don't cramp. It is the ultimate video game playing machine. So let's get started.
Amazing hacks.
Should we take it for a spin?
Inspired designs.
Imhotep's priests.
Regrettable acting.
No one seems to get it.
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
Here's the basis of my analysis system. Whenever the RAM is written to, an interrupt is called on the PIC, where it copies the contents of the RAM buffer into memory. So it copies RAM into RAM. Memory is RAM! All right, so the other thing that happens is it looks for a change in the frame number. So we know the second RAM position is the current frame counter. So if we see that that number has changed from the last version of itself, we do all of our logic code. So basically, if RAM copy is different than frame current, change frame current to new RAM copy, and then we do our logic. So I have this thing called flag on, and that's basically just turning a pin on the microcontroller from low to high. And then at the end of the logic, we have flag off. The reason I did that is so I can hook it up to a scope and actually see how long it takes for the PIC32 to make these decisions. It should be pretty fast, but I want to know exactly how fast. Okay. All right, so the next thing we need to look at is this disassembly in the Stella emulator. So right here we have increment RAM 81, that's the frame counter. So we're gonna trace it and we're gonna count how many machine cycles occur. So increment RAM 81 consumes 5 machine cycles, but we're past that, so we'll start counting after this. So let's go set PC to current line. Okay, 2, 4, 8, 10, 12, 14, 17, 19, 22, 25, 27, 30, 34, and then it loads the switches. Okay, so 34 machine cycles. And also it's about 22 cycles before we saw another RAM access. All right, now let's compare that to the scope. Okay, I have my oscilloscope set to trigger on the rising edge of channel 3. Channel 3 is hooked up to the pin that's attached to the flag command in the PIC32. So basically, this magenta line is showing us the width of time it takes for the PIC32 to make all those decisions. It's pretty fast, although it could change based off what state of the game it's in. Like if I run a game cycle right here, we should see the length of it change a little bit depending on what's going on. Now see how it's shorter and longer right there? That's because every other frame, it's either player 1 or player 2, and it doesn't make any decisions during the player 2 frame, which is why sometimes it's shorter, but in the player 1 frame, it's longer, but it's not that much of a difference. Okay, so the real thing that we have to look into here is the time from the interrupt and then the number of clock cycles total. So let's pause it. So this, the cyan edge right there on channel 2, the rising edge, that is what would trigger the interrupt. Now the interrupt stores the value of the address and the data in memory, but that doesn't actually affect our main loop. Our main loop is running beside the interrupt. So the amount of time it takes for the main loop to make the decision, oh look, the RAM has changed, that could vary, which isn't a big deal as long as it varies within the window of time that we have. So let's take a look. In this situation, it's about 4 cycles. Okay, let's try it again. We should be able to find a change here. Let's see, 1, 2, 3, 4, 5 cycles. All right, so there is a variance. Back to 4 cycles. There it did it in under 3. So if you think about it, the main loop of the program is like, did the RAM change? Did the RAM change? Did the RAM change? What do I do? Update the serial bus, blah, blah, blah. That's always going. But then when there's an interrupt with the RAM, it's like, hey, here's some new RAM. So the time between the RAM changing and the program actually saying, hey, I should analyze the RAM, that can change. That's why we're seeing a window here. But it's not that much of a window. So the real thing is, how quickly does the PIC32 make its decisions? And the answer is really quickly. Like even if we go into a worst case scenario, let's run this again. Waiting for start frame. There we go. See if we can okay, there we captured one of the longs. All right, so what it's doing here is it's taking not even twice the amount of time of 1 clock cycle on the Atari. And we wouldn't actually run into trouble until we got into, remember our count, 34 cycles. Now I have my A and B cursors on the screen here. They're counting the positive pulses between themselves. So let's see, 20 or 34 would be where, over here? Actually, yeah, you can see right there, there's the RAM being changed. That was probably around the 22 mark, 24. Okay, so that's a little different than we thought. So just goes to show you that it's not always gonna be exactly what you think. Yeah, so the 34 mark is probably gonna be over here. Yeah. All right, so we see the difference between A and B on the scope. And basically, channel 3, as long as that pulse isn't longer than the A to B distance, that means our system is updating the controls before the Atari actually checks them. So we have tons of time to spare, but I wanted to check and make for sure with the scope before I assumed anything. So now that I know I'm analyzing things with time to spare, now I can proceed with my coding knowing that fact. I was going through the assembly code in the Stella emulator step by step, and I noticed something regarding the frame counter and the player counter. Now there's some code in the game where it's like, frame counter and 1 equals player counter. So even frames are player 0 and odd frames are player 1. That's what I thought, but what I realized, that's not exactly how it works. So if you look at the emulator here, if we hit frame to go to the next frame, which basically finds the instruction right after vsync, which in this case is increment RAM 81, which is the frame counter. So we can see that it's 38, and over here is our player counter, which is 0, 0. So if I keep hitting frame, we keep seeing this. What we have to realize is we have to increment the RAM. So I'm gonna just step 1 position past that. All right, and then my code, remember, it looks for a change in the frame counter, and that's when it does all its logic. So the frame counter and the player count are actually inverse of each other. The player count is even while the frame number is odd. And the reason that's important is because a lot of the things in memory are organized, they're kind of interlaced like this. So this is all player 0 and this is all player 1. And what it does is it uses the X register to say, okay, if we're player 1, offset everything by 1 in RAM, else no offset. And that's how it actually builds up the scores and stuff. All right, so I know this is sounding really boring, but here's why it's important. So it's important because you want to push the reset button at just the right time so that player 2, which is player 1 in code, has the first time increment, not player 1. So then if we hit frame, okay, so now we see that player 1 at the top, they're at 0, 0, but player 2 has already accumulated some time. So now we know how that actually works. I can make sure my code always pushes reset at the right time. So player 1, the active player that we're trying to test, has the best chance of getting the best time because it's going to save you 0.03 seconds no matter what, just by being the player who pushed reset. And of course that's happening, 60 times a second? So you have a 1 in 30 chance of getting it right, but our system can always get it right. Okay, I have the system dialed in really well. It's doing 5.61 over and over and over. Obviously, we have to do better. So I'm going to put a button menu system onto my board set. We're going to have a menu button, then up, down, left, and right, kind of as control buttons. So we'll create a menu. So we'll have a variable called menu, public menu select. And if it's 0, that means normal operation. So if you tap the menu button, we turn this into, a number. And then once you're in the menu system, up and down will change what number you're on from 1 to whatever. So you'll go through, like 1 will be like starting rev, and it will display, 9 through 15 or whatever. So you can control it with the left and right buttons. So I'm just gonna take all of the simple variables, I'll put them into a menu system that will appear over the serial terminal, so I can make tweaks without having to flash the code every time. I mean, you probably wouldn't run into the theoretical limit of flash erase cycles for that PIC32, but we could, because it's something like 10,000 cycles. So now that I've got it dialed in, I'm going to create a menu system like this. So yeah, menu up, down, starting rev. I'll just put in a bunch of things like, frame start, because we found out that's really important. Frame start 1 to, 1 to 11, step 2, odds. Yeah, and then finally we can also probably get in, shift 1, shift 2, and so on. So that will allow us to dial in the functions even faster than we are right now.
Oh, that looks good. 1, 2, 3. Ugh, we're getting there. I think you probably have to shift faster when you reach fourth gear. 1, 2, 1, 2, 3.
The
or
pop,
1, 2, 3, 1, 2.
Pop in the
Yeah,
clutch?
yeah.
Okay.
I'm sorry. Yeah.
Okay, let's see.
I mean, the beginning looks pretty crisp. Play it again for me, please.
Yeah, sure.
I mean,
feels like
outside-
I'm an editor and you're like a movie director,
I mean, that's really
I'm gonna
good.
change that
Okay,
scene.
1, 2, 3.
So it's good, but we need to do some improvements after third gear.
Yes, and your tap should be sooner in fourth gear. And I don't know what that wobble thing is at the end, other than just popping the gas.
Just let me check something. So shift into fourth at event 55. I'm going to go back to 29. So it seems like I want to shift into third at the latest possible point. But like here, okay, that one fails. So we definitely need to do it at event 28. Let's try it again. So everything from the fourth shift on up, I haven't tweaked yet.
Yeah, I see that.
Do you want me to shift into? So the next question we should get, when should we go to fourth? Sooner or later?
Let's see third gear again.
It's like the optometrist. Is it number 1 or number 2?
Okay, third is good. 1, 2, 3, 4. You see, right after third, it should be already tapping 1, 2, 1, 2, 3, or 1, 2, 3, 1, 2. So you could separate them. How
What
you're.
do you mean by tapping? Tapping the clutch?
Yeah, because when you watch, every time it does a wheelie, you're hitting the clutch. So it's like 1, 2, 1, 2, 3, or 1, 2, 3, 1, 2.
Sounds like you're directing a band now. Do you think we could shift into fourth a little bit later, or?
I think that as soon as you get halfway in your third gear, when you pop the clutch, you should already be in the red on fourth gear, which I'm not seeing here. Replay the performance again.
Right. Yeah, you're correct. You would be a little. I mean, you'd be in the red line, but you wouldn't be at the max.
No,
It's
of course
saying
not,
that
no.
it's at 25 when the clutch is at 25 when you shift into fourth.
Okay.
Yeah, go ahead and watch.
Okay, it should be, instead of receding back here, it should be already here. And then 1, 2, 3, 4.
So we should shift into fourth sooner.
If it's going to keep it in the red, yes.
Okay. Actually, I don't know if that would keep it in. Well, let's try it.
What I'm
Let's-
saying is maintaining the red for the majority part of your shifting is what your ideal shift performance should be.
I'm going to bring it down to 50 just to see how that changes it. Really had a dip on 4 there.
And it also lagged. It didn't like start shifting automatically. It just like waited a little bit. Play it again.
Well, that's because I moved up the fourth shift point, but I didn't move up the pops. So this is just the first pop. Just tell me if the first pop feels good, okay? I haven't adjusted the rest yet.
Yeah, it looks good.
Better time, yeah.
Yeah, we're getting there.
You might bring the other pops down? Compress them down?
Sure.
How many pops do you do after fourth?
5 or 6.
5 or 6?
Yeah.
Okay. How many are we doing? We're doing 8 post
I mean,
fourth.
I've gotten 5.57s with a 6 pop, so it's
Manually, by hand. I have to cheat with the computer.
1, 2, 3. There's a little bit of hesitation there, and then that little wobble at the end.
Yep.
Which
I still need to. I can move more of them up.
Okay.
So it's fourth, 1, 2, and then the third one you're saying is off.
You can put them like this. As soon as it goes from third into fourth, it's 1, 2, 3, 1, 2, 3, or like 1, 2.
So
yeah.
Sooner yet.
Yeah.
The post pop? Okay. All right, so the first post fourth pop is in the same place, but then I spaced them out more from 10 to 12.
That's pretty good.
And time got better too.
Yeah.
Oh. It's
Well
power of the computer internets.
I'm thinking that maybe we're in third too long.
You want to go into fourth sooner?
Yeah.
You can do that.
Let's try that. I mean, everything looks ideal. I mean, the second gear is really, really spot on. Third gear, you're not lagging too much time in it. You're, in a sense, giving it enough to where it's in the red and then shifting to fourth. So right now, Ben is setting up the device so it can read OMNIGAMER'S spreadsheet, and we're going to do some comparative shift start patterns. We're going to run his program of his valuations, and with the different start values, we're going to see if we're going to get the same result each time.
Yeah, so we can iterate through the starting frame automatically. It'll just restart the game over and over. Yeah, let's give that a run. I don't know if I typed in everything correctly. Nope, I must have missed something. Let's see, what did I miss? Okay, so here is the unaltered spreadsheet. I'm going to put a 1 over here, and I'm going to have it just number all these things, because we can't use the column number because that's actually, that would be incorrect. So let's do series. I like how you can just type something into that and it shows you exactly where it is in Word. I wish Adobe products were as consistent as Microsoft Office. Okay, so that's our event number, see? So that's the number we put into our computer, because my program goes by events and frame numbers, not time.
Okay.
Okay, so I'm going to punch in these numbers and we'll see if it replicates a 557. Oh, there it is. Okay, so looks like we got this punched in well, so yeah, what does this tell us, or how could we tweak this? Any ideas?
Well, I think we should just do the testing with the starting points like we do with mine, and see what the results are if they change.
Oh, the frame iterations, got it, yep. 1 second. Okay, so I'm gonna go into the menu, and I'm gonna go to, let's see what frame, okay, we're starting on frame 0. So let's go into auto run test with frame increment, yes, okay. So now it's going to do it with frame 0, then it'll do it with 2, 4, 6, 8. Who do we appreciate? There's a 557. Now we're starting on frame 2. Okay, now that blew. Wow, that was like 577.
Indeed.
0.2 of a second different. So yeah, even the frame number you start on, look at how much of a difference it makes.
Absolutely.
Also, the audio circuit I wired up is extremely...
That was a 574.
Extremely rudimentary.
That was another blown.
Let's see, what iteration... Okay, so this is... The next one should be a 557 again, because we've looped around to 8.
Right.
Yep.
And that little shift, the waver at the end, doesn't apply in the later ones because its interval's a lot different. And I don't even know why it's wavering at the end. It's either you're gonna fan the gas or you're gonna pop the clutch.
Just a second. I'm going to go back down to 0. It seems like it does a pretty good job of not losing the red line in fourth. Yeah, I mean, it dips into the green very briefly.
Right, and that's what I was trying to mention on the earlier time when we were analyzing, is that at not one point where, when I played years ago, did it go back into the green as what we've been looking at recently.
It looks like it, maybe very briefly, if not at all. I can't imagine how many times you'd have to actually play this to get these numbers.
A lot.
Because look how difficult it is to dial it in, even with the computer system.
Absolutely.
Versus like your hands.
And then controllers that are 40 years old and a system that's equally as old. And of course timing. You know, you want to make sure that you're hitting that joystick at perfect interval time, hoping that the joystick will reflect that into its game.
Okay, Todd, we did a lot of testing with Dragster and the electronic rig.
Indeed, we did.
So what did you think of the results?
I think that there's a lot more testing to be done, as well as me playing it on the actual hardware and filling that to see comparatives when I get into 554.
Yeah, I mean, there were some limitations that kind of held us back. The way I should do is I should make it so there's different modes where you can like go into practice mode. So we talked about like starting on the correct frame. Now for a human, that's kind of difficult, but the computer can do it every time. So right now, like we push the button and the thing starts the game and then also plays the game for you. We could have a mode where it just starts the game for you. So it'll push reset at the exact right time, but then you put in your inputs. So
Right.
you'd be controlling the game. So basically it would just be pushing start.
So it's more than just holding a joystick and tapping it 8 times to the left, correct?
Yes, it is very complicated because if you change one variable, everything else changes. Well, that's all we have for today. Todd, thanks for coming on the show.
Thank you for having me.
So what did you think of our analysis? We have the hardware working, but what about our numbers? Did we crunch them properly? What kind of things should we try? Let us know on the Element 14 community at element14.com/TBHS. You can also go there to read about other upcoming episodes, builds, and special events. We'll see you next time in a drag racer way.
Who will challenge me? Which arcade video game is that from?
Sinistar?
No, Joust 2.
Oh. No, it wasn't 27. Kaboom.
Hey, it's another game by Activision. Kaboom. To build a time machine, build that to him as well. This way we can
Time
travel
machine?
back and see the actual performance happen. The original one at the house, and then the 2 live ones, and then problem solved.
Well, maybe he could say his name is Mr. Fancy Dancy, and he's like, I'm not calling you that.
But people call me Chub.
You can call me Chub.
How's it any better?
It also makes no sense.
Well, it's shorter.
You go from stupid to idiotic. And you can have the people laugh at him. They can't turn their head and laugh. How the hell can you keep a straight face if you have the part in a movie? Don't call me Chub.
Hey Ben, the community had asked that you make a portable of this.
A portable version. Of course they did. I think it'd be better to use a Raspberry Pi. So I've got an idea. So the Raspberry Pi can do a lot more than just HDMI. I'm going to unsafely eject it. Potential security breach. Hey, that's great. It means that I'm connected to the Pi. Fatal error. Oh, I didn't sudo it. Son of a beeswax.